Hello guys, welcome back to this Fiat Ducato van conversion series. In the previous episode you saw us remove the headliner and that plastic parcel shelf, and we fitted that reversing camera. And in today's video we now need to insulate that area above the cab. By insulating that area above the cab, what we want to try and prevent is condensation forming, which is going to give us problems with moisture in the future. So what materials can we use in that area to combat that problem? A lot of you may not know, but I'm a mechanical services engineer. I spent many years at university studying the properties of insulation and then applied it in my working life to commercial buildings. We used to always have to prevent condensation forming on large metal ductwork for air conditioning systems, huge great big metal pipes for chilled water installations. So the application of insulation and prevention of condensation has been a big part of my whole career. So in today's video I want to apply some of that knowledge to our van build. And the best way to demonstrate that is to draw a temperature profile across the structure of the van. So I'm going to do that on the whiteboard. So let's have a look at what's actually happening through the structure of our van. So we've got a steel skin, which is metal, very thin, probably 1 or 1.5 millimeters thick. Let's say that we're in cold conditions. The outside temperature is -3 degrees C, just for argument's sake. And the inside temperature of our van is nice and warm. Let's say it's a toasty 21 degrees C and probably about, let's just say 50% relative humidity inside the van. Outside at -3, it's probably going to be 100% saturated because it's so cold. So it will be 100% relative humidity. We'll insulate our van with some form of insulation. So we'll put an insulation layer here. And then the van will be clad with a ply lining, tongue and groove, or whatever material on the inside of the van. Now let's have a look at what's happening to the temperature across that structure. Outside it's very cold, -3, and there's a surface boundary air layer on the outside of your van which offers a very little bit of resistance, so that temperature actually will increase very slightly before it gets to the skin of your van. Fractions of a degree. Then it will transfer through the steel structure of the van really easily, because steel as a metal conducts heat very easily and it's only very thin, so the temperature will be a little bit higher than -3, but not a lot. Again, a 0.1 or 2 of a degree centigrade by the time it's on the inside surface of your van. So that metal surface inside will be very similar to the temperature outside. Then as we go across the insulation, that temperature, because of the thermal properties of the insulation, that temperature will rise until it gets to the surface of the cladding. And depending on the thickness of the insulation and the properties of that insulation will determine how much that temperature rises before it gets to the inside of your cladding. And then obviously there's some thermal properties to the ply lining and the tongue and groove battening or whatever you're using to line your van. So again, the temperature will rise very slightly across the thickness of that wood, and then it will emerge. The surface temperature of that wood could be something in the region of, let's say, 12 to 13 degrees, depending on how thick this insulation is. If it was thicker than this, that internal temperature could be, say, 15 degrees by the time it gets to there. And then you've got a final surface air layer, boundary layer, which would increase the temperature a little bit more. And then the rest of the temperature rise is done in the space till we get to the 21 degrees inside. So how thick does the insulation need to be to make sure that that surface temperature is above the dew point and we won't get condensation forming on the insulation surface? Now the problem is At some point along this temperature gradient in your insulation, we're going to hit a temperature which is going to be below the dew point. So that means the air inside will be fully saturated, it can't hold any more moisture, and condensation is going to start forming. Now, I know from psychrometric charts that at these conditions, that dew point is something like 10.2 degrees centigrade. So at 10 degrees inside your insulation on that thermal graph, if you like, that's when condensation is going to start happening. And that's going to start happening within your insulation in your van. It's also going to start happening on the skin of your van. Beads of condensation are going to form here, because you're allowing that air, that warm moist air from inside, to get through your cladding into your insulation, and it's going to get colder and colder as it gets to the surface of your van. That's where the condensation is going to form. So what we do to prevent that is we put a vapour barrier here on the warm side of our insulation. And then what that does is that stops that moist air from getting through your insulation to where it can be cold enough to start forming condensation. Now, there's a minimum thickness that the insulation needs to be to prevent that happening on the surface of the insulation. So if your insulation, you can see, is only a couple of millimeters thick, the surface temperature of your insulation is going to be below the dew point. So you could get condensation forming on the surface of your insulation and your vapour barrier. So at these conditions, that minimum thickness of insulation needs to be 6 millimeters. So we need to provide at least 6 millimeters of insulation on the surface of our van with a vapour barrier to prevent any condensation on the surface of that insulation, and to stop the moisture getting through the insulation to where it can condensate on the steel of the van. So that's why I've selected this closed cell foam for the overhead cab insulation. This is 10 millimeters thick, so it's thicker than the minimum I need to ensure that I'm not going to get condensation on the surface of this insulation. You can use closed cell foam on its own because the properties of it is inherently it's its own vapour barrier. It's a closed cell construction, so moisture won't get through there. I've actually selected a product that's got a foil face on it as well, so I'm kind of doubling up on the vapour barrier. So I'm 100% happy that no moisture is going to get through into my insulation where it can start forming condensation actually in the insulation itself. It's got a self-adhesive back, so we can stick this to the metal of the van. Really simple to apply. So this would be the minimum that you could insulate your van with to prevent any form of condensation happening. Obviously, ideally you'd want the insulation to be a lot thicker, generally everywhere else in your van, for the thermal properties, to reduce that heat loss to outside. The thicker the insulation, the better the thermal properties, the warmer it's going to be inside your van, and the less energy you're going to have to use to heat it. We've done the insulation in 2 halves. Because of the size of the roll, it's not wide enough to do the whole ceiling, but it's a convenient point, the midway point there, and then it goes right the way through to a crease where the vertical side of the van starts. It's about 850 mil, that section, because the whole van from crease to crease is about 1700, so 850 wide, and then a section about 800 long is enough to tuck up into that top section there, and 2 or 3 inches to tuck right the way down as far as you can into that bottom piece there. Just a little tip to get it down in between the sheets of metal. I've left the last couple of inches of the adhesive. I've just split this so that that's not going to be exposed, because believe me, this stuff's so sticky, if you peel the whole thing off you're never going to get it down behind in between those two bits of metal. So just leave the last couple of inches like that and then peel it from there back. It will make life a lot easier when you come to install it. Cut it there. So that's the over cab space all insulated with that closed cell foam, self-adhesive. It's stuck on there nicely. I foil taped all of the joints, and where I could, as much as possible, made sure that it's tucked right down as far as I can towards the screen. So all along the back of that edge there, it's tucked all the way down there. We've done it in two sections, as you saw. And then the side pieces, just a case of cutting the similar profile. Again, making sure those joints are all taped. And then it's really a case of mitigating any condensation that's potentially going to build up above that cab area. Now with that stuck on there and that vapour barrier, that'll be nice and warm up there. There won't be any issues with condensation above the cab. I wanted to show you this free bit of software that was available online from Armacell. They're an insulation manufacturer of closed cell insulation primarily. And they've got this free bit of software online where you can actually put some information in and calculate the minimum thickness of insulation that you need, depending on what your conditions are. So let's just run through. I'll put some links in the video description below to this page where you can download your own software and have a go yourself. Okay, this is the home page. You start off by clicking on New Calculation. Then we enter the project title. I'm going to call this Fiat Ducato van. Oops. We're in the United Kingdom. I'm going to metric symbols. I want the thickness to be calculated. ISO standards. I want it to predict where the condensation is going to occur, so I'll leave that ticked. I'm going to take into consideration the wall of the van, so it's a vertical surface. Select vertical. And then it's a wall, so select wall. Now the material of the wall is steel, so we'll select steel. The height of the van is 2 meters. And the wall thickness, I'm going to say, is 1.5 millimeters thick. The medium is air, basically, because you've got air both sides of the van walls. And then it's a transportation vessel, if you like. And if we pull this one down, we can select caravan or RV. And then we can select Armaflex sheet, which is basically a closed cell foam sheet, which is what I want to calculate for. There are, if you go on show more, there are a lot more options for different installations that you can look at and you can calculate, but for the purpose of this demonstration, I'm going to pick this closed cell. and it automatically fills in this information here, which is the emissivity of the surface of the insulation. Leave those as they are. We're in outdoor conditions where the van is. Now the line temperature is the temperature externally. So let's pick a cold situation. So let's say it's -3 outside. This is in centigrade. The internal temperature, let's say it's nice and warm. We're going to pick 21 degrees, same as our previous example I did on the board. And we're also going to pick that 50% relative humidity that we were looking at earlier. Leave the wind speed at 0. Obviously, wind speed does have a variation on how much heat is transferred, but we'll leave that at nothing for this purpose of this calculation. And then we just simply hit the calculate button down the bottom right hand corner. And there we go, there's all our figures. So now it's calculated that the minimum thickness needs to be 3.8 millimeters. The dew point will happen at 10.2, which is what we looked at earlier. And here's our temperature gradient, which is very similar to what I showed you on the board earlier. So we're -3 outside. There's a slight increase before we get to the steel of the van. There's no increase in temperature across the steel of the van because steel's a really good conductor. And then most of the temperature increase happens through the thickness of the insulation. And then you've got that last boundary layer on the inside of the van before we get to the internal van temperature. And this dotted line is what we were talking about earlier. This is the dew point, which is that 10.2 degrees centigrade. So at this point where those two lines cross in your insulation, that is potentially where condensation could be occurring. Because you're getting closer and closer to that cold temperature, the temperature's dropping and you're reaching that saturation point. But obviously with the properties of closed cell insulation, that's not going to happen because you've got that vapor barrier there. That moisture's not going to get into your insulation. If you just had a wool-based insulation like recycled plastic bottle insulation or even sheep's wool or anything that's permeable, then that condensation would start forming within the thickness of your insulation before it even got to the steel wall of your van. Yes, it will happen on the steel wall of the van as well, but it will also happen within your insulation. So it's a really handy tool to use. As I say, the links are in the description. Click on it. It's completely free. Download a copy yourself, have a go, put some different information in. You can go back, change the values. We can put, say, a colder temperature in here. Let's go down to -10. If you're thinking of going somewhere really cold, let's calculate that. Oh, and there we go. Straight away, it's put up the minimum insulation thickness that we need. To make sure that our internal surface temperature is above that dew point. I mean, let's go back and change the conditions inside. Let's change the humidity, increase the humidity to 70%. You know, let's say you've been doing some cooking in there. It's really humid inside your van. Let's calculate for that. Yeah, see, that makes a huge difference. See, if it's really humid inside your van, then that insulation needs to be thicker even still, because what that increase in humidity has done is it's raised the dew point quite dramatically from 10 degrees to 15 degrees. So now that insulation needs to be at least 19 millimeters thick to stop condensation forming on the outside. So it's a real handy little calculator to have a look at. So everything that we've discussed today is talking about the absolute minimum that you would need to do in terms of insulation to prevent condensation forming in your van. But we don't want to do the absolute minimum in our van, in this particular van, so we're going to be using a combination of materials. I'm going to be using PIR insulation, which is what we've used before, because the thermal properties of this is really good. And I'm going to be using a combination of 25mm and 50mm thick, 50mm in the walls, 25mm in the floor, and that'll give us some really good insulation properties. It's also got its own vapor barrier as well. I'm also going to be using this recycled plastic bottle insulation in all the difficult voids and all these pillars and these beams and the beams in the roof. we're going to be using this woolen insulation because it's just easy to shove into all those gaps. We are going to be using some more of the closed cell foam on some of the areas, different thicknesses of closed cell foam. And then lastly, I've got a huge roll of vapor barrier, the double foil bubble that we've used before, to make sure that all of our insulation on our van is encased, so none of that warm moist air can get through to that cold steel and we won't have any condensation issues. So there's more to come on the insulation of this van. We're going to be insulating the floor to start with, so that'll be one of the videos coming up very shortly. So if you found any of this interesting, please do give the video a thumbs up. If you know somebody else that's doing a van conversion and you think they'd benefit from this series, then please do share the videos on social media with your friends and family. And I look forward to seeing you in the next video. Cheers!